Hello, welcome to another video by Mox Marine. This video I want to introduce you to a new addition to the family. This is a 5.3 liter Gen 4 LS engine. I don't know the exact code yet, but I'll find out and put it in the description of the video. I do know it's Gen 4. It's got an iron block, aluminum heads, active fuel management, flex fuel for larger injectors, Trailblazer SS intake. You can tell that because it's got the map sensor up front. The older style truck intakes had the map sensor back here. And like I say, I got this core for about $350, including a 4L60 transmission to go with it. Pretty sweet deal. So as you can see, it's got the it doesn't have variable valve timing because it would have a phaser right up in here. But it's got that front-mounted cam sensor, just like I've explained in other videos, which is pretty neat. Get a nice cover with that, and the distributor, the cam sensor bracket and coil, bracket and harness adapter there. Anyway, the one thing it's missing is it doesn't have ignition coils on the other side. I'm gonna see if the owner can send me those, and may have to pay extra for that, but it'd be worth it. The one thing I wanted this motor for was this Trailblazer SS intake, because it's got steel fuel rails. Plastic is not allowed on a boat, so I wanted this steel fuel rail, and it's got a non-return system. You see it's got a supply in, but there's no return on this. So you have to use a Corvette fuel filter, and I'll explain that in another video. But like I say, the main purpose I bought this was for the intake, the fuel rails, and the valve covers. I believe that's it. And the rest of it I'm gonna keep and rebuild to another engine. It's got the heads on this have a number called 243 right there. Those are very desirable heads. These are the last heads, or these are the best, what's it called, cathedral port heads. Cathedral port is like this, where you got a very high pointed port right here. So instead of a rectangular port, you got a pointed port right here at the top. That's called cathedral port. These are also, I believe these heads are also 243s here. Let's see if we can find the number. Yep, 243. So those are nice heads. So I've got a decent motor, nice heads, iron block, front cam timing cover. That's about $100 worth of stuff right there. And that's pretty much it. Okay, to strip this engine down, so far all I've done is I removed this is called your canister purge solenoid. It's installed as activated electrical signal from the computer, and it has a hose running from the there's a charcoal canister somewhere on the vehicle that connects here, and then there was a hose that ran from here over to your intake, and that's what this is what allows the engine to purge your canister. In other words, it sucks gasoline vapors out of the canister and burns them through a charcoal canister, so that the canister can absorb more fumes. And it only does that when it's underway. It doesn't do it at idle, because you can actually mess up the mixture at idle. But had that happen to me in another vehicle a long time ago. Anyway, I removed this canister. You don't need it on the boat. It's going in the trash can. I'll have to figure out a plug for this eventually. There's a special connector that fits on here, but I'll hopefully make a plug that's designed for that purpose. All right. Then I removed the map sensor from this location. I unbolted the ignition coil pack, which was that right there. Unbolted it from the valve cover, and then I removed the valve cover. And so I'll show you the reason I'm doing that is eventually, in a second, I'm going to rotate this engine over with a torque wrench and watch all my valves rotate and see if this engine rotates and is still a working engine as far as rotation functionality. If it won't rotate at all and something's broken inside, or if it does rotate, I might see valves not moving all the way like they're supposed to. That'll indicate a bad camshaft. I was told the reason he got rid of this engine was it had low oil pressure. It was running up to that point, but it had low oil pressure, so we had to swap engines. Like I said, this is active fuel management, so if I had to guess, it's because the cam lobe got wiped, or a cam bearing walked and dropped the oil pressure. So one thing to note about this type of engine, when I'm stripping this down, if I was going to reuse this, not rebuild it, but reuse as is, like buy a junkyard motor and just clean it up a little bit and put it back in the car and run it. If you take this intake manifold off at all, you want to drain the oil, get the oil completely out of the engine, drain your oil, remove your filter, let the engine drain out, then flip it upside down and take this intake off. Because the reason I say that, because there's a whole bunch of trash collecting. Trash collects down in here and underneath here, and over here. And if you take this intake off with a motor upright, all that trash will fall straight into your cylinder, and you don't want that. So again, if you're gonna reuse it and you want to take the intake off, flip it upside down, and all your trash will fall away from your cylinder. That's just a little tip I want to give you. All right, I'm gonna continue breaking this thing down. I'm gonna remove the motor mounts on both sides. I'm gonna remove all that trash on the back of the intake here. By the way, this is the this rubber hose is your brake booster connection. It goes to your brake booster, which is down here. There's your oil pressure sending unit right there. This is a protector for your fuel rail. I guess in an impact, there's a, so that's what that's for. So this is, if the engine gets hit in the impact, this bar right here keeps that fuel rail from getting hit during the impact. So this is that's what that brace is there for. Let me think what else. This is just a static plastic cover. I'm going to be taking all these bolts off the back and taking this out of the way next. And then my goal is I'm trying to get this intake and these fuel injectors off and get them out of the way. Okay, I just got the intake off this engine. Like I said, if I was going to rebuild it, I would have drained the oil, flipped it upside down before I took the intake manifold off, and this is why. So this is what was underneath that intake manifold on this engine. What a mess. Acorns, obviously the squirrels have been living up in this engine or hanging out in this engine. This almost could have dropped in there. Once it gets in the cylinder, you probably don't get it out. You have to take the cylinder heads off and get this out of here. So this is kind of mess I'm talking about, where you don't want this spilling over into your engine. But since I'm going to be rebuilding this anyway, taking the heads off and rebuilding it doesn't matter. But yeah, this is the kind of crap that you're going to see on these older engines. So I'm going to go ahead and get this cleaned up. I'm going to vacuum this off and then continue breaking this engine down. In a previous segments video, I stated I was going to rotate the engine, see if it was in good mechanical shape. At this point, I can't do that because I didn't take the flywheel off and the flywheel bolts before mounting on the stand. So it's binding up on these bolts, so I can't rotate it. I'm not really care. It doesn't matter. I'm going to rebuild it anyway, so I'll just continue to tear it down. All right, let me get this cleaned up, and the next thing I'll do is this is called your Loma. Trying to remember what it stands for, but it's what this is a manifold. This is your active fuel management system. You got connections to your computer here, and that's what there's 4 solenoids in here that control oil pressure to your lifters. There's special lifters inside this engine. I'll show you in a second. And those lifters are what's called they're activated and deactivated by oil pressure. So this when the computer wants this thing to go into a 4-cylinder mode, it directs oil pressure to special lifters which disengage, and then it allows it to kill that cylinder because the valves no longer operate. And that's how it works. But let me get this thing cleaned up, and then I'll get the Loma manifold off and proceed with getting these heads off. Okay, I've got this mess vacuumed up. I removed those 2 pieces of foam rubber, thrown them in trash. I've gotten all the acorns and dirt and everything vacuumed off this motor. This is, like I said, this is a Loma manifold. I'm throwing it in the trash. I don't care. I'll take the sensor off of it and save that, but the rest of it's going in the trash. Because if you notice on this other engine, I got a flat cover there. That's the Corvette version. Corvettes didn't have the active fuel management. So we're using the Corvette cover. I don't want this cover. It's prone to leak. So we're just going in the trash can, or it's going in the recycling, but rather. All right, let me go ahead and get it off, and then that'll free me up to where I can. Next thing will be so you have what's called steam ports. That's what this is here, and that's a pipe that goes to your radiator or to your cooling system to let it release the steam. When these engines are stalled, the front is higher than the back, so any steam and air goes to the front and it's bled off at the front of the cylinder heads. If you notice, the back is already sealed off. They used to put vents on the back here too, from this side, from here over to here, but they no longer do that, so you only have to vent from the front. All right, let me keep going to get this engine torn apart. Okay, I now have the Loma manifold off, or manifold's probably redundant, but I have the Loma off, and you see this active fuel management. These are active fuel management towers. That's where the oil pressure goes down your lifters and disables them. I'll get the heads off next, show what those lifters look like, but you see that, so this is the manifold. It's called the Loma. And a lot of gaskets on the LS engines are reusable. They're metal substrates with metal substrates with a rubber seal. And they're reusable, but this one is not, because it's kind of clipped into this housing here. There's something that's anchored it there. It's plastic too, so I'm just not going to save it. I'm going to get a new gasket for this engine. I'm going to get a new cover anyway, so I get a gasket with it. All right, so right this time I'm gonna go ahead and move this. I'm gonna remove this bracket, and then I'm gonna start pulling the heads off this engine. Okay, before I can take the heads off, I have to take these valve lifters out, not lifters, these rock arms, and you take them out by doing each one at a time. There's a bolt here, bolt there. These are 15 millimeter or 8 millimeter, same thing. So you have to take all 8 of these loose, take them and get them loose, and then you lift this whole tray. This is a tray underneath. Lift this entire tray out all at one time, and then that's how you get the valves out. While I'm gonna do this, on the last engine I built, there was some interference. This tray had some interference right down here. I'm gonna see if this has the same kind of problem. I'm curious about that. But I'm gonna go ahead and get these rock arms. And by the way, I like to keep the rock arms in the same place, so I try to keep them on this this tray, this lifter, the rocker tray here. And I also like to identify the starboard versus port side, so I can put them back on the same side on this particular cylinder. So what I'll probably do is put a scratch in one side just to indicate which side it goes. I'll put maybe a L for 2 scratches to indicate L, and L would be, let me try to think, I guess if I'm sitting in the engine, to me that'd be the driver's seat in the car. So anyway, I'll make a mark somehow to indicate which side it goes on. But I'm about to disassemble all these rock arms and get them out of the way. Okay, I've now gotten the rocker tray off, and I'm gonna go ahead and label this with an S for starboard or starter, either way, because the starter's always on this side, so I call it S for starboard or starter. I've got these 10 millimeter, or actually 10 millimeter head, 8 millimeter bolts for the cylinder head. There's 5 of them up here. The other bolts are torque to yield. You do not want to reuse those, so when you take them out, throw them in the trash, or do something, hit them with a hammer, bend them so you know not to use them again, because they're not reusable. They're torque to yield. These up here are not torque to yield because you torque them to 22 foot-pounds, and that's all it takes. So you can either throw them in the trash. You'll get a new set when you buy a new set of cylinder head bolts. You get new bolts up here, but you can save them for some other purpose if you want to. So I've got a bucket of bolts that came with this engine when I bought it from the previous owner, and I'm just throwing all the bolts in that bucket. Unless for special purpose, like the Loma bolts that were up here, I put them in a special box. I put them in a separate box and called it the Loma bolts, and the location where I bought this engine. All right, so moving on, I'm about to loosen the head bolts and then take these heads loose. First, I'm gonna take all the spark plugs out and check the condition of the threads and make sure all these the threads on the cylinder head are in good shape. I'm curious about that. Okay, I now have all the spark plugs out, and I've never heard of this brand. It's called HIV or High Vehicle, HI Vehicle, HV110. Never heard of it. They look kind of cheap. This one's kind of concerning me because the electrodes being in a little bit. And then this one here is real concerning. Was it this one? No. This one looks like it's either got a lot of anti-seize on it or the internal engine is toast. There's a lot of glitter on this spark plug, and a lot of oily looking stuff, but it could have just been a lot of anti-seize on it. We'll find out. The threads didn't seem to be stripped, but I'll find out later. Anyway, got the plugs out on that side. Now to take the cylinder head off and see what's going on with this engine. Okay, now I have the cylinder head off on the starter side, or starboard side, as you want to call it. I don't see any major issues wrong. It looks like there might have been a possible fuel head gasket blown right here on this side, because you can see how the ring, all the rest of the cylinders, you can see the ring goes all the way around on the edge of the cylinder. And on this one, it's not brown, it's more black right in there. It starts disappearing and being black, but it's actually maybe not, it's just the lighting here. So I think everything was fine. And it looks like the previous owner may have just put too much anti-seize on the bolts and spark plugs. So I think the cylinders are fine. So one thing you have to watch out for when you take a cylinder head off, this is called your cylinder head dowel. It's your locating dowel. The other one came off with the cylinder head and fell out on the ground, and I saw it and I picked it up, put it in a bucket. I'm about to pull this one out and put it in a bucket so I don't lose it. And next thing I'm gonna do is pull these lifter trays out and pull the lifters out. And I'll show you what a active fuel management lifter looks like. I believe the active fuel management on this side of the cylinders 4 and 6. These two here. As a matter of fact, I'm positive because I can see those lifters down in there. Those are active fuel management lifters. I can tell already just how the differences are. All right, let me get these lifters out and just see what they look like. Okay, I now have the cylinders. This will be 8 and 6 on the starboard side, and I've got the lifter tray pulled out, or the lifter tray. And it left 2 of them in there. It left number 8 lifters in there. I'll pull them out in a second. But you can see it. These are the active fuel management lifters. They look different and they're spring loaded. Let me go ahead and try to get these out for you so you can see what they look like. Okay, this is what's known as an active fuel management lifter. You see it's got the spring on top of it, and the way oil pressure enters this thing, I'm not exactly sure how the mechanism works, but I know that when oil pressure is applied to it in one of these ports, I'm guessing it's this small one right here, when oil pressure is applied to that port, it makes this lifter collapse internally, and then this spring is just what's holding the tension on the lifter to keep it from flopping around. And then the push rod rides up and down on the spring, but the lifter doesn't. The lifter internally is compressing and not pushing the valve open. So that's an active fuel management lifter. This one appears to be okay. The roller looks great, so I believe this lifter was still functioning. I'm going to go ahead and get the rest of the lifters out on this side, and we'll see if we can find any bad ones. I'm not going to save this because I will probably never use it, but actually I will save it. I just will. I may use it one day in the future, but not for now. If I ever have to fix my own car or somebody else's car that needs it repaired and needs this lifter, I'll save it. All right, while I'm working on the starboard or the starter side of this engine, I went ahead and removed some stuff off the front here. I removed the air conditioner bracket, which is bolted here, the 2 bolts here. It's supposed to be bolted by a 3rd bolt, but that bolt is a long bolt that helps hold part of the AC compressor itself in, so it wasn't there. And it looks like the hole's been filled up with dirt dauber. If you're not from the South or you don't know what a dirt dauber is, it's kind of like a wasp. It fills up holes with mud, it seals it up with their larvae in there, and they fill up every single hole they can with dirt, so kind of pain in the butt. So then after I got the AC bracket off, I went and moved the motor mount. The motor mount was attached to these 4 bolts here, or these 4 holes here, and got the motor mount off. Then I removed the knock sensor bolt. The knock sensor came out. Removed the crankshaft position sensor, which goes right there in that hole. Take it off. Oh, I had to get the starter. I took the starter off first. It was 13 millimeter head bolts holding the starter in from the bottom. Remove the starter. Remove the crankshaft position sensor. So now the starboard side of this engine, starter side, is all cleaned off, and I'm going to move over to the other side. I believe that hole is plugged. There's nothing in there. Usually that's a oil level sensor or something, but I don't see one in there. So now we're going to do the other side, get the head off the other side. Once I get it to that point, I will drain the oil, flip it over, and take the oil pan off. But first I have to take the horn-mounted bouncer off to get the oil pan off. But let me get the other side of this engine done first. Okay, I now have the cylinder head off on the port side of this engine. And we had problems in the cylinder number 7. There's 1, 3, 5, 7. 7's got water in it, some rust in the cylinder. And the LS engine, that indicates something. So the LS engines are kind of special or unique in that you'll never have water in that plastic intake. There's no water passes in the intake. So the only place water travels through an LS engine is the water enters. It enters the block here in this hole, goes through the cylinder head, and comes back, goes back down, and goes back through the water pump this passage. So there's no connections between the intake and the cylinder head for water. So if water's in that cylinder, it means either a blown head gasket or a cracked cylinder. There's no other way water can get in there. So I'm going to go ahead and pull this head gasket off, examine it, and see if it had a blown head gasket. Okay, I got the head gasket off. I do not see any sign of a blown head gasket, and now I've had second thoughts. I believe what happened, by the way, this water or liquid in here, I put my finger in it, does not feel slimy like antifreeze, so this is just water. I believe what this was rainwater. When I got this engine, the cylinder head was just here and the exhaust port was open, and I believe it was just a matter of rainwater getting into this cylinder. So I don't think that indicates anything particularly bad, but I'll know more once I get the cylinder out, or get the piston out of the cylinder. By the way, these pistons are flat tops. They're not the dish type, so this engine was a high performance engine. And I'm curious about what kind of horsepower this thing was rated for. But all right, now the head's off, I can go ahead and pull these lifter trays out, and I'm almost to the point where I'm ready to take the harmonic bouncer off the front, get the timing cover off, and remove the camshaft and see what condition the cam's in. Okay, I now have all the lifters out. Oh, by the way, I'll pull the trays out. I'm saving them in this tub down here. Probably will never need them or use them again because they're active fuel management lifters, but I'll save it for a future anyway. But the bottom line is that I've got all the lifters out. I inspected the rollers, and I see nothing wrong with these lifters. So that makes 16 lifters that seem to be in pretty decent shape. So this is becoming more and more of a mystery as to what's wrong with this engine. He said it was misfiring, or no, he said it had low oil pressure. So maybe it wasn't misfiring at all. Maybe it just had low oil pressure. Some of these spark plugs were kind of questionable, so I think he had some cheap spark plugs in there. I'm not sure if it would have caused low oil pressure, but it's, I don't know how it could have damaged the engine like this. But I have yet to figure out why I had low oil pressure. So it's now time to, and I don't see any blown head gasket symptoms over here. So now it's time to get this harmonic bouncer off and get the front timing cover off, get the cam out, and see what condition the cam's in. So to remove a harmonic bouncer, you have to have a special, I think it's called this combination Chrysler, but it's a tool that has fingers that reach in and grab. There's some little ears in here, and so you can see them here. Yeah, right here. So there's an ear right there, ear right here, and an ear right down there. So that this device grabs a hold of these little ears and pulls it out. First, you got to get that bolt out. That bolt in there is probably in there about 200 and something foot-pounds, so that could be a bear to get out. I'm gonna have to get a 4-foot breaker bar more than likely to get that loose. Okay, I've just removed the harmonic bouncer from this LS engine, and there's the bouncer there on the floor. And I use this tool. It's doesn't have a part number. It's Chinese. I bought it off Amazon several years ago. Don't remember what the part number is. I'll look it up and post it in the description, but it comes with that triangular puller. Here it is, triangular puller with the bolt, and then these 4 rods just for the depth. And I just pulled this harmonic bouncer off of this kit. It's not made for this. According to this, it doesn't cover up through, it says Gen 3, 97, let's see, GM 97, Gen 3, 2000 Gen 3. It does not say anything about after that. Cadillac 88 to 92, and so on. So it's not really designed for General Motors, but it just worked. It was kind of a little bit sketchy, but I was able to make it work. So I really don't recommend this tool for this purpose, but I made it work. If I can find the proper tool, I'll post it in the description so you can buy that instead. Okay, now that the harmonic bouncer's off, I'm gonna go ahead and try to remove this front cover. I'm gonna first remove this the cam sensor and the cam sensor harness attachment here. Get that out of the way, and I'll remove the cover, and then see what kind of see if the cam's got any damage after we pull the cam out. All right, I now have access to the front timing cover, or to the camshaft, and the oil pump and the timing chain. If you notice, this is a single bolt cam. The earlier models with the, and this is also what's called a 4X cam sensor gear. So you can see it's got these 4 raised areas. That's called the 4X cam gear. And it has a single bolt in the middle. So the ones that use the 1X cam gear have 3 bolts in the middle, 3 smaller bolts. So I'm gonna get that bolt out and take this cam out. I can't get the cam out until I get the oil pump out of the way. And I can't get the oil pump out of the way because the oil pickup tube is bolted to the bottom of it right in there. There's a nut or a bolt right inside there that you cannot get to with the oil pan on this engine. I don't know if that's a design flaw or somebody put the bolt in the wrong spot. You would think that they would put the bolt in here. The clamp that holds this pickup tube should have been on the bolt rope. There's a bolt hole right here where my finger's at. They should have put the bolt in there to hold it on so you could get to it and replace your oil pump without having to drop your oil pan. Maybe that's what you're supposed to do. Maybe not. Not sure. But anyway, I'm gonna stand still now because I can't get this cam out without getting this oil pump out of the way, and so now I'm gonna have to drop the oil pan to to finish this up. Okay, picking up where I left off, I went ahead and removed the oil pan while it was still upright. Drained the oil, took the filter off first, drained the oil, which wasn't a whole lot in there, and then I removed the oil pan while the engine was still upright and just pulled it off the bottom. Once I got that off, I flipped it upside down and I removed the oil pickup tube off the top. It's over in the trash pile now. They're not worth trying to clean. They're like brand new $25. It's not worth the labor to try to clean them out. So I'll buy a new oil pump pickup tube. But so the oil pump pickup tube is now off. It was attached here, and to the oil pump, which is gone. So after I got the oil pump pickup tube off, I took the 4 bolts out, holding the oil pump on, slid the oil pump off, and that's where I'm at now. Okay, I've got this single bolt cam bolt out of the center of the cam, holding the cam sprocket. And let me make, while I'm at it, let me make a comment about this. So as I was discussed already in this video, you got what's called a 4X cam gear. It's got these 4 raised positions on here. That's what you use when you have a 58 tooth crank trigger wheel. If you go with a 24 24 tooth crank trigger wheel, to the best of my knowledge, you cannot get a 1X cam gear with a single bolt. So if you were to buy like an LS3 camshaft that has, again, the LS3 camshaft has a single bolt here, it's going to come with the 4 raised notches and not the 1 single notch. So bottom line is that you must use the 3 smaller holes, an LS2 camshaft or an LS1 camshaft with 3 smaller bolt holes anytime you use a 24 tooth trigger wheel. So I just want to point that out while I got this thing open. So basically what I'm saying is this gear to me is worthless to me because I'm not going to use a 58 tooth trigger wheel on any of my builds. Okay, like I said, I removed the gear, and then I removed the, first I removed the chain tensioner. I destroyed it in the process because I'm not going to reuse it anyway, it's so old. So I removed the chain tensioner, then removed the gear and the chain, and then I pulled the cam retainer plate off. It had 4 Torx bolts in it. And then I pulled the camshaft out, and again, this mystery is getting even deeper because I see nothing wrong with the cam. I see nothing wrong with any of the lobes. All the lobes look pretty good. Let's look at them here. Yeah, I see nothing wrong with these lobes. So, like I say, he said it was low oil pressure and it had a misfire. So apparently the cam was good. So, and I see nothing wrong with the cam bearing. So I don't see any cam bearings that walk. So unless this thing's got a bad rod bearing, I have no idea why the oil pressure went low. So I'm going to go ahead and I'm going to go ahead and pull the windage tray off, and then I'm going to take the rod bearings off and see what we got for rod bearings. Okay, I've now moved all the pistons and rods out of this 5.3 LS engine, and still not sure about the code. I'm waiting for the owner that I bought it from to tell me what the VIN number is of the vehicle so I can figure out what this engine code was. I believe it's LMG, but I'm not sure. But I took out all the pistons and rods, and every one of the bearings was in this shape here. This is almost excellent shape. I mean, it may be a little dirt on there because I've set it down, but should get a better, give it justice here. You probably can't see it at the camera, but these bearings are in great shape, all of them. So there was no problem with any of the rod bearings. So this, again, the mystery getting deeper and deeper as to what caused the oil pressure on this engine. The reason it's sitting on the ground is I had to take the flex plate off the back, and you can't get to it with it on the engine stand. So I lowered it down to the floor. I've got a come along over there. Lowered it down to the floor. I wedged the crowbar between the flex plate and the block down here, and then I removed all the 6 flex plate bolts, and then got the flex plate off. Now I'm loosening up the main bolts, and I'm going to pull this crankshaft out. Once I get the crankshaft out, I'll inspect the main bearings. And by the way, that bearing I just showed you, the rod bearing, was a General Motors GM part standard, so this has not been rebuilt before. The owner said it had almost 400,000 miles on it. If it did, this thing was in phenomenal shape for 400,000 miles. So, all right, let me go ahead and get this crank out, and we'll see what the bearings look like. Okay, to wrap up this video on disassembling this 5.3, above this is an iron block 5.3, and I believe it's an LMG. So I've got all the, I got the crankshaft out, and all the main bearings look pretty good. So this only one had a blemish on it. I got a dog over here, it's the mascot. So anyway, that's the only blemish on the, that's a main bearing, or that's the thrust bearing. That'll be number 3. This is in great shape. This is which one was this? This was number 1, because I number it. Number 1's in very good shape. Hush, boy. Number 1 was good shape. Let's see, this is number 2. Again, this is in excellent shape. So bottom line is all the bearings look similar. None of them are in bad shape. Actually, all of them are in great shape compared to how many miles it's got on it. So the only thing it possibly could be, this cam seems to have a little wear ridge in there. Right in there, you can see it like this spot right there, right above my fingernail. There's a little ridge. I can feel my finger, but it's barely there. I've never seen that before. But anyway, I'll knock the cam bearings out. If the cam bearings happen to be a problem, I'll leave it in the description of the video. I haven't got them out right now. But let me show you what I think may have happened. And these engines are known for doing this. This is the only thing I can think of that's left. So this is the oil pickup tube, and this O-ring here seals the oil pickup tube to the oil pump. And if it leaks right here at this O-ring, you'll have a vacuum leak and it will not be able to pump. And this seal feels kind of brittle. It's not very, it's not soft and flexible and pliable like a brand new one. So, hush. So I have a feeling that this might be the source of the oil leak or the oil pressure problem. There's other videos on, I won't cover that, or I won't do a specific video about that problem. It's all over the internet or all over YouTube about this problem. I'll link to a couple of those videos in my description of this video, but this is the cam bearings or this seal right here are the cause of low oil pressure in this engine, because I could not find anything else wrong with this engine. It's in great shape. As a matter of fact, I'm probably gonna rebuild this without having to, I'm not gonna turn the crank. I'm not gonna rebore the bores. I might hone the bores and that's it. So it's gonna be a lot cheaper to build this engine than I thought, because it's in pretty good shape. All right, that wraps up the disassembly of 5.3. It was a great bargain. Now it's time to put that other one over there together. Thanks for watching.